In this video, we are going to be looking at what makes something an acid or what makes something a base. There's two main ways that chemists define acids and bases. So we'll take a look at these and we'll also talk about how you will see these types of questions on the Regents exam. One thing that you want to have in front of you is your reference table. Specifically, you want to have that open to page 6 where we can reference the common acid and common base table. All right, so the first one that we're going to talk about today is the Arrhenius theory. So this is just, somebody's name. A lot of times the Regents will use that word Arrhenius, but really you just have to think which of the following is an acid. It doesn't really matter about the definition. So this is the main one that we'll be using in Regents chemistry. Acids are substances who, when they ionize in water, they produce the hydrogen ion. So if you take a look at, say, HCl, that's going to be our most common acid. So if that is added to water, it will ionize into the hydrogen ion and the chloride ion. And it's the hydrogen ion that makes it be acidic. Yes, the chloride ion is there, but that doesn't really do anything to the pH. Since there's a lot of hydrogen ions, that's what's going to make the pH lower. So acids ionize to make the hydrogen ion. The more hydrogen ions you have, the more acidic that particular thing is. Bases are going to be substances that ionize to make the hydroxide ion. So if you take our most common base, NaOH, if we add that to water, that's going to ionize to make the sodium ion and the hydroxide ion. And if we look at our common base table, 3 out of 4 of our bases have hydroxide in it. So that should help you remember that. And then again, things are more acidic when they have more H+, more basic if they have more hydroxide ions. All right, here is a very common question that we would see on a test, a quiz, or on the Regents exam. So according to the Arrhenius theory, when a base dissolves in water, it produces. Okay, our main idea is base. So it doesn't really matter that it's the Arrhenius theory. It's the fact that we have a base. So bases ionize to make the hydroxide ion. Now let's say that when you got to this question, you forgot. If you recognize base, then if you go to table L, our common base table, again, you see 3 out of 4 of them have hydroxide. So therefore, hopefully you would pick that. Now it does say as the only negative ion in solution, because let's say we have sodium hydroxide, then you would also have the sodium ion too. So that's why they say as the only negative ion. All right, next example question. The compound HNO3 can be described as what? All right, so again, we want to take a look at table K, table L. So if we see on table K, HNO3 is classified as an acid. So HNO3 is an acid. So therefore, we need to not be picking 3 or 4. So it's an Arrhenius acid. Here's the definition. If that confuses you, you can even cross out. It's an acid. And then we have to remember if acids conduct electricity or don't. Acids do conduct electricity when dissolved in water. So choice 1 is our answer. So here we have another example. So it says an Arrhenius acid. Again, if the word Arrhenius confuses you, you don't have to worry about that. It's basically saying an acid. So which one of these is true about an acid? So acids don't have hydroxide. Hydroxide is OH minus. That's bases, so that's not our answer. Only hydrogen ions. Acids definitely do have the hydrogen ion. Number 3, they have hydrogen ions as the only positive ion, or hydrogen as a negative ion. That's not true. So 3 is our answer. The difference between 2 and 3 is 2 is saying this is the hydrogen ion's the only ion floating around in the solution. 3 is the answer, because if we have something like HCl, we're going to have hydrogen ions in there, but we also are going to have chloride ions in there too. So hydrogen's not the only ion, but it is the only positive ion. All right, this is something that's going to be important for us to remember. The hydrogen ion is H plus. In all actuality, that's really reactive and it does not exist by itself. So the H plus ion combines with a water molecule to make the hydronium ion, H3O plus. What we need to know is that the hydrogen ion and the hydronium ion can be used interchangeably to indicate the presence of an acid. So that is something that we definitely need to be aware of. And we might have back-to-back questions. In one question, they might talk about the hydrogen ion. And then in another one, they talk about the hydronium ion. And they're both used to indicate the presence of an acid. In all actuality, hydronium is more accurate because, again, the hydrogen ion is too reactive to be by itself, so it combines with the water molecule to make the hydronium ion. However, for simplicity, a lot of times people just say that you have the hydrogen ion because it's more obvious if we have like HCl that you're going to get the hydrogen ion than that you're going to get H3O plus. But either way, hydrogen ion, hydronium ion, both indicate the presence of an acid. All right, on this slide, we have another definition of acids and bases. This is the Bronsted-Lowry definition. The Regents exam won't ever use the term Bronsted-Lowry. They'll just talk about an alternate definition of acids and bases. So in this definition, which is a little bit more broad than the Arrhenius one, so this allows a few more things to be classified as either an acid or a base. Acids are classified as things that donate or lose H plus. Bases are classified as things that gain or accept H plus. So what we want to do here is you want to look at your reactants and what do they look more like on the product side. So NH3 looks more like NH4 than it does OH minus. They're pretty similar. So you partner them together. Those are called a conjugate acid-base pair. In order for NH3 to turn into NH4 plus, it had to gain an H plus. Therefore, NH3 is classified as the base in this example. Water would get partnered with OH minus because water looks more like OH minus than it does NH4 plus. In order for water to turn into OH minus, it had to lose an H plus. So therefore, water is classified as an acid in this case. Now we have one of those silly things to help us remember that. So people who do acid are losers. So that helps us remember that acids lose H plus. Now, a lot of times the Regents is going to use the term donate or accept, but accept would be the same thing as gain. Donate, you're giving it away, so it's the same thing as losing. All right, here's a few examples on that Bronsted-Lowry theory. So first thing you do is you partner up the two things that look most alike. So HCl looks more like Cl minus. Water would partner with H3O plus. Okay, HCl, in order to turn into Cl minus, had to lose an H plus. So therefore, HCl is acting as the acid, which should not come as much of a surprise because we know HCl is an acid. Water is turning into H3O plus. In order to do that, it's gaining or accepting an H plus. So therefore, water is acting as the base in this particular example. All right, if we take a look at the next one here, H2SO4, you would partner that with HSO4 and water with H3O plus. H2SO4, in order to turn into HSO4, has to lose or donate an H plus. Therefore, H2SO4 is acting as the acid. Water is gaining an H plus in order to turn into H3O plus, so water is acting as the base here. Next example, HSO4 is turning into SO4 minus 2. In order to do that, it must lose an H plus, so that is acting as an acid. Water is turning into H3O plus, so it's gaining an H plus, so water is acting as a base. Next example, NH3 would be turning into NH4 plus. In order for that to happen, NH3 must be gaining an H plus. Gaining would be a base, HCl, turning into Cl minus. In order for that to happen, HCl has to lose an H plus, so therefore it's acting as an acid. Here's a Regents question that asks about the Bronsted-Lowry theory. So notice they just say one acid-base theory. They don't use the name Bronsted-Lowry. States that acid is, and we just said, acids will lose H plus. So that would be the same thing as donate H plus. Here is another question on Bronsted-Lowry theory. Again, they just said an alternate theory of acids and bases. So if we read through our choices here, it wouldn't make sense that acids and bases both do the same thing. So it would make way more sense that they have to do opposite things. So we can eliminate choice 1 and choice 2. Then we need to think, okay, acids will lose H plus. Bases will gain H plus. So the one that best matches that would be choice 4. Acids donate H plus, bases accept H plus.